Hello students, how are you all? I hope you are very good and fine. Today we are going to start exercise 8b of chapter 8 HCF and LCM. First of all, we will discuss how to find out the HCF of the given numbers. So there are three methods to find out the HCF. First one, common factor methods. In this method, first of all we find all the factors, then find out the common factor and which factor is highest, that will be the HCF. And then prime factor method. In this method we find all the prime factors and then find out the HCF. In division method, in this method we divide the greater number by the smaller number. About all these three methods I have already discussed in the previous video, so you can watch the video to know these methods in detail. In this exercise we will discuss some questions. So start the question number 1, that is using the common factor method find the HCF. Question is, you have to use this method, common factor method, and find out the HCF. So question number 1, part 5th we will solve. This is question number 1, part 5th. This is 24, 36, 45 and 60. Method is common factor method. It means we will find out the factors of these number, then find out the common factor, then we will find out the highest common factor. So first of all, find out the factor of 24. The factor of 24 will be 1, 2, 3, 4, 6, 8, 12 and 24. These are the factors of 24. How can we find out the factors of 24? That is a proper method. I already explained you in part 2. That is 1 and number itself are the factor of each number. So the factor of 24 will be 1 into 24, these two factors. Then this is even number, so divide by 2. So 2 into 2 1 ja 2, 2 2 ja 4. This is 12. So this is 2 and 12 are the factors. And 24 will be divided by 3 also. 3 into 8 and then 4 into 6. 5 is not divide. 5 does not divide 24. So the factor of 24 will be 1, 2, 3, 4, 6, 8, 12 and 24. This is the proper method. 1, 2, 3, 4, 6, 8, 12 and 24. Similarly, find out the factor of 36 will be 1, 2, 3, 4, 6, 9, 12, 18 and 36. 1 and number itself are the factor of all the numbers. Then factor of 45 equal to 1, 3, 5, 9, 15 and then 45. Factor of 60. Factor of 60 will be 1, 2, 3, 4, 5, 6 and then 10, 12, 15, 30 and 60. So these all are the factors of these given numbers according to question common factor method. So first of all we will find out the common factor. Common factor are 1, 1, 1, 1. 1 is the common factor. Then 2, 2. There is not 2. So 1 is not, 2 is not common there. 3, 3, 3, 3. 3 is common in all the factors. And 4, 4. There is not 4. 6, 6, 6. There is not 6. Then 8. There is not 8. 12, 12. There is not 12. And then 24. There is not 24 in these numbers. Only 1 and 3 are common. Only 1 and 3 are common factors. and then nothing is common there. Only two factors are common. Which is highest? Our question is highest common factor. So the highest common factor is 3. This is the answer of this question. So the HCF of these questions, these numbers, is 3 only. Now question number 2, using the prime factor method, find out the HCF. So part 5th we will solve, that is 12, 16 and 28. First of all, we have to find out the prime factors. Method is prime factor method. So find out the prime factor of all these numbers. First of all, we will find out the prime factor of 12. This is the proper method to find out the prime factors. Divide by 2, then 2 6 is 12, again divide by 2, 2 3 is 6, and divide by 3. So its prime factors are 2, 2, 3. You can write here also 2 into 2 into 3. Now prime factor of 16, this is even number. Divide by 2, 2 8 is 16, again by 2, 2 4 is 8, again by 2, 2 2 is 4, again by 2, 2. Its prime factors are 2 into 2 into 2. Now the prime factors of 28, this is an even number, can be divided by 2. 2 1 is 2, 2 4 is 8, 2, 7, 7 and 1. Its prime factors are 2 into 2 into 7. Now our question was there, method is prime factor method. These are the prime factors. Now find out the common. 2 is common, 2 is common, all these numbers. So HCF will be 2 into, again 2 is common, 2, 2, 2, and then there is 3. There is not 3, 7, nothing is common there after 2 and 2. So only 2 into 2 are the prime common factors. 2 2 is 4. Then HCF will be there 4 of these 3 numbers. So using this method, first of all find out the prime factors, then find out the HCF. Which factors are common there in all these numbers? Right here first, that will be the HCF of these numbers. Now question number 3, third question, using the division method. Now in this question we have to use the division method. So question number 3, there are 5 parts also. We will solve part 5th, that is 32, 56 and 46. In division method, which method we have to use? Division method. In this method we divide the greatest number by the smaller one, but there are 3 numbers. So first of all we will divide 56 by the second largest number, and then after finding the HCF of these numbers, that HCF will be checked with 32. So any 2 numbers you can use. So we will use first of 56 and 46. So which number is greater? 56. So first of all divide 56 by 46. 46 1 ja 46. Subtract, this is 0 and this is 1. Remainder is 10 there. Now this remainder will be the divisor and this 46 will be the dividend. So 46, now 10 4 ja 40. Now subtract, this 6 will be remainder there only. Now 6 will be the divisor and 10 will be the dividend. 6 1 ja 6. Now remainder is 4. Again 4 will be the divisor there. 6 4 1 ja 4. Remainder is 2. Now this 2 will be divisor and this 4 will be dividend. 2 2 ja 4. Now this means the largest divisor of these 2 numbers is called the HCF of these 2 numbers. Now we will check this HCF with the third number. So divide third number by this HCF. This is 2, 2 1 is 2, remainder is 1, bring down 2, 2 6 is 12. Means this HCF is verified with 32. Now overall we can conclude that 2 is the HCF of all these three numbers. What we have to do in this method? First of all, use any two numbers, find out the HCF of any two numbers, divide the larger number by the smaller number, follow the proper method. The remainder will be the divisor for the next step, and first divisor will be the dividend. So follow the proper method, and at last we found the HCF of these two numbers. Then verify this HCF with the third one number which is left. So we have verified this number. Now 32 is completely divided by 2. It means we can conclude that the last divisor of all these three numbers is the HCF of all these three numbers. I hope you have understood how to find out the HCF using all these three methods. These are common division method first. In this method, find out the common factors, then find common. Then HCF prime factors. First of all, find out the prime factors of the given numbers. Then find the HCF in the division method. Divide the larger number by the smaller number, and then check with the third one number if three numbers are there. If only two numbers are there, then simply you can find out the HCF by the same method. Suppose that there are only two numbers, we have to find out the HCF by the division method. So simply divide the greater number by the smaller one. 12 1 12, remainder is 4. Now this remainder will be the next divisor, and 12, the divisor will be the dividend. So 4 3 12. Simply this last divisor of the division method of the process is called the HCF of these two numbers. I hope you have understood these questions of exercise 8b. Now next question. Question number 4, that is, use a method of your own choice to find the HCF. Means any one method. I have explained you three methods. Out of these three methods, you can use any one method and find out the HCF of these three numbers. So by your own choice, you can use any one method. But in this question, I will give you a different method, that is, you can say the fourth method, that is the common division method. That is a very easy method, and commonly this method is used there to find out the HCF. And this method is as follow. That is, first of all, write all these three numbers in a proper sequence, then divide these numbers commonly. Then the method is called common division method. So first of all, we will divide a prime factor which divides all these three numbers. This is an even number means all these three even numbers will be divided by 2. First of all, divide this. 2 2 4, 2 4 8, 2 1 2, 2 8 16, 2 4 8, and 2 8 16. Again, even divided by 2, 2 1 2, 2 2 4, 2 9 18, and 2 2 4, 2 4 8. Now this is even, but this is odd, means all these three numbers are not divisible by 2. So we will check by 3. This 3 4 12, 3 3 9, 3 8 24, means all these three numbers are divisible by 3. 3 4 12, 3 3 9, and 3 8 24. Now no one number is there which divide all these three numbers. So commonly three factors are there. Three prime factors are there which divides these three numbers completely. It means the HCF of these three numbers will be 2 into 2 into 3. So simply you can write HCF equal to 2 into 2 into 3 equal to 2 2 4 3 12. This is the HCF, very most common method. Most of the people, most of the students use this method to find out the HCF because this is very easy method. Now in most of the questions we will use this method also. So in question number 4, this method is used up. The remaining question you will solve by yourself. Question number 5. Find the greatest number that divides each of 180, 225, 315. 180, 225 and 315. We have to find out the greatest number which divides all these three numbers. It means greatest means highest, highest means HCF. We have to find out the HCF of these three numbers. So simply this method we will use there. Even, odd, odd means these numbers will not be divided by 2 commonly. Check with 3. This is divisible by 3. This is divisible by 3 also. And this is divisible by 3 also. So 3 6 is 18 and 0, 3 7 is 21 and 3 5 is 35. 3 5 is 15, sorry. 3 1 is 3 and 0, 3 5 is 15. If you have any type of problem, then you can divide separately. 3 1 5 divided by 3, 3 1 is 3, bring down 1, not divided by 3, take 0, again bring down 5, 15, 3 5 is 15. So simply you can do the rough work if you have any type of doubt in this division. Again, this is 60, 75, 75. Now both the all these three numbers will be divisible by 3 also. 3 2 is 6, 0, 3 2 is 6, 1 is remainder, 3 5 is 15, 3 3 is 9 and 1 is remainder there, 3 5 is 15. Now all these three numbers cannot be divided by 3. So 20, now 5 4 is 20, 5 5 is 25, 5 7 is 35. This is 4, 5 and 7. No one common number is there that will divide all these three numbers. So the HCF of these numbers will be 3 into 3 into 5 equal to 3 3 is 9, 5 is 45. And this is the answer. This is the highest common factor that divides, highest common number that divides all these three numbers completely according to question. This method you can follow. In the solution, different methods you can have, but no problem, you can use any one method to find out the HCF. If a question asks about the method, that you have to use that proper method. So that method you have to follow according to question. Otherwise you can use any one method according to your choice. Question 6 is, show that 45 and 56 are co-prime number. Question is, so that 45 and 56 are co-prime number. You know what are the co-prime numbers? First of all, let to know co-prime. You have ever seen there that some numbers are there which has only one is common factor. Suppose that this is 12 and this is 9 and this is 16. If we find out the factor of 9, there will be factor of 9 will be 1, 3 and 9 only. And factor of 16 is 1, 2, 4, 8 and 16. So what is the common factor? Only one is common there. Only one is common there out of these factors. So you can say that in 9 and 16 only one is common factor. It means these numbers are called co-prime. So the definition of co-prime is the numbers that have only one as the common factor is known as co-prime numbers. So our question number 6 is, show that 45 and 56 are co-prime numbers. So to show this process, first of all we have to find out the factors of these numbers. So factors of 45, 1, 3, 5, 9, 15 and 45. These are the factors of 45, and factors of 56 equal to 1, 2, 4 and after 4, 7, 8, 14 and 28, 56. These are the factors of 56. Which is the common factor? Only one is common there. Only one is common there. So you can say yes. First of all, right here. The common factor is one only. Hence, these numbers are co-prime numbers. You can write this statement also. So find out the co-prime numbers. First of all, we find out the factors of both the numbers. If they have only the common factor, then you can say these two numbers or given numbers are co-prime numbers. The next question, question number 7. Out of 15, 16, 21 and 28, find out all pair of co-prime numbers. Means you will check the 7th question by this method. Question number 8. Find the greatest number that will divide. Find the greatest number. Greatest means highest. Highest means HCF. So find the greatest number that will divide 93, 111 and 129, leaving remainder 3 in each case. Means remainder should be 3 in each case. So to find out the highest number and remainder must be 3 in each case. It means first of all subtract 3 from these numbers. So the number will be 93 minus 3 equal to 90. 111 minus 3 equal to 108. And 129 minus 3 equal to 126. Now find out the HCF of these numbers. And then these numbers will be divided completely by that HCF. And if you divide these numbers by that HCF, so in each case 3 will be the remainder there. You will solve this question by yourself. And this is the solution of exercise 8b. I hope you understood all the questions. If you have any type of doubt in these questions, you can ask through the WhatsApp or YouTube also. Thank you, students.